One team,
one mission,
one map.
The nationally available Search and Rescue Common Operating Platform, also known as SARCOP, was developed over a 3-year period through a partnership between DHS Science and Technology, the NAPSG Foundation, or also known as National Alliance of Public Safety GIS, and FEMA. The groundbreaking tool dramatically increases the effectiveness and efficiencies of search and rescue field operations before, during, and after an emergency response operation.
SARCOP stands for the Search and Rescue Common Operating Platform. It's a multi-agency mapping platform that helps, first and foremost, first responders in the field, but also gives information for the Emergency Operations Center who need to make critical decisions to support them.
Things kind of came together in 2017 with a series of a few storms that ended with a bunch of us on the beautiful island of Puerto Rico in response to Hurricane Maria. Folks there, the FEMA teams were using iron sights. From there, I think the ball started rolling downhill quickly for the folks at NAPSG. The two gentlemen that I know most intimately involved in it are Jared Doak and Paul Doherty. But they seem to rapidly version up on that. And next time I really came across and used it thoroughly probably was in the run-up to the Champlain Tower collapse. And then at that Surfside collapse, it was in use quite a bit.
When we redesigned SARCOP, we built it off of a mobile platform, a smartphone, and used apps that were familiar to firefighters. We made it as easy as possible, and that's really why it's been successful.
After disaster strikes, there's an immediate need for urban search and rescue teams, commonly known as USAR. These specialized teams are critical in the aftermath of incidents ranging from hurricanes and wildfires to tornadoes, floods, and building collapses. Their mission is clear: to locate and rescue survivors trapped in damaged or collapsed structures, provide emergency medical care, and assess the stability of the buildings.
So SARCOP has evolved out of many, many years of work done in and around geospatial and search and rescue operations. I can trace it all the way back to support to 9/11 and even some things done prior to that. S&T continued to advance our relationship with FEMA and Urban Search and Rescue Program at large.
SARCOP was designed for the search and rescue personnel in the field, but it's used by the 28 FEMA Urban Search and Rescue Task Forces, as well as state and local task forces across the nation. It's used for building collapses all the way up to swiftwater flood response like we see today.
I deployed with FEMA's Urban Search and Rescue system, and we trialed these various systems during hurricane responses because it provides a common language for the operations and planning folks to collect data and information, or really all the stuff coming into the situation unit. Those can be things like locally collected search data before we get there, search data from us after we get there, human intelligence gathered from informal conversations with local residents or responders, typically coming from operations personnel. It can be orthoimagery, either from the existing incident management organization or gathered by our GIS folks before we arrive. We can visually depict that data and information, really enabling us to be very clear about progress toward the incident objectives.
Really, the community has built this tool, SARCOP, for themselves. They've been involved in all of the process of design, testing, redesign, and it's really, we like to say we didn't build it, they built it.
We used a very similar application that was originally designed for warfighters in Iraq and Afghanistan. When it was evident that the USAR system and the nation as a whole for search and rescue were moving towards another platform that utilized ArcGIS, we were very interested in that and jumped on board when we saw how dynamic and how easy it was to utilize all of the different features.
The best tool for first responders are the ones that they already know how to use. And so in their day-to-day work, they're using a variety of different technology platforms. What we've done with SARCOP is we've used it to create a common map that can unite all these platforms, to use a modern technology platform that gives them the best available geospatial information that they could have never had many years ago. And this is what's critical. They're not just using paper maps and institutional knowledge, they're using the latest flood model or the latest tornado track or the latest impact zone from an earthquake. It really helps them target in on where they need to search.
However, the biggest challenge USAR teams face is the sheer intensity of their work. Their activities are incredibly labor and data intensive. Historically, they've had limited access to the kinds of technology that could make their processes more efficient and effective. Historically, it has been difficult to pinpoint where to search, keep track of areas that have been searched, and identify the next locations that need to be prioritized.
For example, during Hurricane Debby, it allows them to see everything from where is the general area of flood risk down to where is there a risk right now using flash flood warnings, all the way down to where does it normally flood.
What you're seeing on screen here is a result of the searches from the recent hurricane and tropical storm Debby in the South Carolina area. Specifically, we're looking at a neighborhood that is downstream of some dams that were considered to be potentially endangered by the flooding. You can see all the green dots are structures USAR members assessed and found to be in good condition. Specifically looking at white diamonds with purple targets in them, those are a symbol that we use for targeted search. And those were placed from members at the BOO looking at the national dam inventory for these dams that would be considered to be at risk. In addition, on those rivers, besides just the dam inventories, we also added flood gauges so that we could see live what stage of flooding they were at risk of. When they would update it, we had the Army Corps of Engineers flood inundation potential layers for worst case scenarios for how far the water could reach.
As you can see in this screen, this is the search coverage analysis, the wildland fire incident, which expanded to a town and then actually burned over the whole town. FEMA Urban Search and Rescue was assigned here to conduct wide area search. We used the SARCOP to look at our initial area of operations, and that informed our initial strategies and tactics. After we started to conduct search and rescue and had some more informative data, we were able to use the responder track logs, and that really helped us understand how much search could be conducted in one day by one particular resource. And that gives operations an idea of how many additional resources they may or may not need. You can see here, there was a main road that they used to access the area, and then they would spread out from there. You can see the different types of searches here based upon the things that the responders found and the different levels of search that they would go into for each of the various structures based upon what they noticed and using their knowledge, skills, and expertise to help them with that.
There were 2 fires in the panhandle of Texas in early March of 2024. I'm going to zoom in on the Windy Deuce fire because that was the first one that we did any search activities on. Texas Task Force 2 is one of the state's urban search and rescue teams. Their headquarters are in the Dallas-Fort Worth area. So they were the first on scene performing search and rescue. They circumnavigated the fire outside of the burn area and came in from the north to this area. This was the most affected area of the fire. I'm going to zoom in some more. And what we have is a lot of search tracks that were laid down by Texas Task Force 2, as well as the damage report that the state was looking for with our damage observation. The most affected and destroyed areas of the town with the wind coming out of the southwest and driving the fire to the northeast. And all of this information was put into SARCOP by the search team managers for the search segments.
We're putting this in the hands of first responders so they can see the exact buildings that they need to go to conduct a search.
The damage data that they collect is vital, as it forms the foundation of the overall emergency response to disasters.
The National Alliance for Public Safety GIS Foundation, or NAPSG, has been working since 2005 to bring together first responders and GIS experts, mapping experts. And this time, it wasn't just about conversations. We began building with the support of DHS Science and Technology that allowed us to prototype, design, refine our work, get out in the field, test it out, and then come back with better solutions than we would have if it was just volunteers working on their own.
Developed by NAPSG Foundation in partnership with DHS Science and Technology Directorate, the Search and Rescue Common Operating Platform, or SARCOP, leverages existing technology to improve coordination, efficiency, and the effectiveness of USAR operations. NAPSG Foundation provides this capability at no cost to USAR teams, and it partners with FEMA during larger disasters.
People always come first, and the people we're talking about are first responders trying to help survivors, bring them to a place of safety. We need to understand the process for that, whether it's a flood or an earthquake, so that we can help them. We don't just develop technology and then give it to them. We work with them in the field to understand what they're trying to do, to make it easier, to support them, and then build the technology. What we did with this grassroots approach is we invited everyone in. We worked closely with innovators, but we worked closely with the laggards, the people who are hesitant to try new things. And as a result of this, we helped all of those groups.
Anybody can put information into it at the local level, at the state level, and at the federal level.
That just simply wouldn't have been possible without this system and before the current maturity of the system.
SARCOP is a critical link in that collection and dissemination.
All incidents start local and end local, so if it doesn't work for them, we don't want to use it. And I think that's why we've been really successful working from the local fire department up to a regional team, up to a state team, and that's really been the success of that.
With SARCOP, USAR teams can make faster, more informed decisions, ultimately saving more lives. It's a critical evolution in how we respond to disasters, and we're excited to share more about how this technology is transforming our operations.
We've already have adoption from all of the FEMA urban search and rescue teams, many of the state and local, but we still have disasters today where we show up and they're not familiar with SARCOP and they didn't know it existed.
The efforts that S&T is taking at this point is really looking to advance the application, make sure we're meeting the needs, the requirements of all levels of search and rescue, and ensuring that the technology is available to all these teams in the future.
I often think of science and technology as a test bed to try out creative ideas. Some of them will make it, some of them will take a few years. That's what innovation is all about. However, with SARCOP, it's been adopted so quickly and the demand so great. It's expanded even beyond my initial vision. The team that's working on it, especially NAPSG Foundation, we need support because now it's been used across the nation.